All right, so back to to finish our discussion on multidimensional arrays, and then we'll be done with all of our array talk. Okay, so in the same way that we processed through a single array where we could input values from a user, we could print all the elements, we could sum them all up, something like that, random shuffling of an array. All of these things, we can do that with a two-dimensional array too. There's just a slight difference in that we need a second loop to deal with it, because now we need to not only go through the outer array, we also need to go through the inner one to do all of that as well. So if we wanted to initialize with input values, we go through all of the outer arrays, then we go inside of those and go through each item inside of the inner array, and we get a new value for it. Okay, so we go through one by one saying you need to input the next value. So whatever the row, column. So the first time through this loop, row is 0, column is 0, we're getting the first item. Then row is 0, column is 1, we're getting the second item in that first array. Row is 0, column is 3, column is 2, then 3, then 4, all the way up to whatever the length is of that first row. All right. Then once we're done with that first row, we go back to our outer loop, we add 1 to row, row becomes 1, assuming that's not the end of it. Then row is 1, and we go through each value, each column in that row, getting a new value. Same thing with random input, same thing, we gotta have 2 loops, one for the outer, one for the inner. Same thing with printing them, same thing with putting all the values out. We need to go through the outer, go through the inner. So we need to add up all the values, go through the outer, go through the inner. It's the same thing as the previous single one-dimensional array. Right. Now here's a little bit of a different thing. We might want to say, okay, what if I want to add up all the values by their columns? Okay, so basically want to add up everything in column 1, everything in column 2, everything in column 3, and so forth. Okay, well, then what we can do is we can go through each column, right? Now this assumes that it's a rectangular matrix. This assumes that all the columns counts are the same for all of our arrays, which may not always be the case. Okay, but let's assume that it is for this example. Then what we do is we go through all for each column. We say, okay, take the row, right? Take the value in a row at that column and add it to my total, and keep adding it until I'm through with all the rows, and then say, okay, the total for that column is whatever the total is. Then go back and do the next column. Then go back and do the next column. Then go back and do the next column. Okay. So this is a slightly different take. Right? This would be like adding up all the values in the column. We can much more easily do if we were saying adding up all the items in a row and showing what the total is. It'd be a little bit easier. All right, because in that case we wouldn't have to assume that all of the row sizes are the same. We wouldn't have to assume that every row has the same number of columns. All right. Here again, random shuffling becomes quite a bit more complicated, but we still need to go through each item in the array and randomly swap it with some other item in the array. And so what we do is we still have to loop through the outer and the inner, and then we just figure out, instead of having one other random index, we have to come up with 2 other random indices, right? Because we need to randomly swap it with something somewhere else, right? Which would mean 2 other index values we need. Okay. Same way with the passing an array to a method or returning an array from a method. Same thing. It's just a matter of now we just have to pass it. We just have to declare it as a 2-dimensional array in our parameter list. Okay, I'll show you guys an example of that in just a moment. Okay. This problem, we'll talk about this. We'll talk about grading a multiple choice test if each student gives a different set of answers, but we have one array that is the correct set of answers. Is how do we grade that? Okay. I have another problem with which is finding 2 points nearest to each other. This is our array of different x, y coordinates, and we want to find out which ones are closest to each other. That's an example. That one example is in the folder that is shared with you. We probably won't go through that one today, though. And then I love to play Sudoku. I don't know if anybody else does, but I really like it. It's relaxing and also hopefully sharpens my mental skills. All right, but basically the idea of in a Sudoku is every row needs to contain the numbers 1 through 9 with no repeats. Okay, so you have 9 positions, and every row needs to contain the numbers 1 through 9, no repeats and no missing. Okay, same thing with each column needs to contain the numbers 1 through 9 with no repeats and no missings. And then finally, each 3x3, so each 3x3 box contains the numbers 1 through 9 with nobody missing and no repeats. So these are the rules, right? So you're given some starting numbers. There's also a version of it called Killer Sudoku that gives you no numbers but gives you little regions of what they have to add up to. So that's a little bit more math heavy. But there's also a couple other different versions of Sudoku, but the main one that most people know about is this one where they give you some starting numbers and then you have to fill in the empty spots with whatever number is supposed to be there. Okay, all right, so so this would be a solution. Now every Sudoku has only one valid solution. All right, so let's just go ahead and put that out there. All right, and so we want to check whether or not our solution is correct. And what we'll do is we will have a program that will use a multi-dimensional array, a 9x9 array, to check if our Sudoku solution is correct. Right? So we'll look at that example in here in just a moment. Okay. Now, we've talked throughout this whole lecture multidimensional arrays as being a two-dimensional array, as being an array of arrays. But remember one thing I said earlier is, well, what if each thing in that second dimension, what if each of those pointed to another array and we had a three-dimensional array? Or pointed to another one, we had a four-dimensional, or 5, or a 6. This is all possible. This isn't a problem. We can do that. We can have a multidimensional array of, so here is an example of a three-dimensional array where each outer array, each of these represents a student, for example. Okay. So each of these represents a different student in our course, in our what we're doing. We're scoring their exams. Okay. Now, each of these inside, so this array, right, is which exam? So here, this could be the first exam, this would be the second exam or assignment or whatever you want to call it, or quiz, third, fourth, and fifth. So each student has taken 5 exams or 5 tests or whatever. Okay. And then we're even saying, okay, this score is whatever they got on the multiple choice part. This score is what they got on the essay part, the writing part. Okay, so let's say that this exam, each of our exams in this class, this hypothetical class, had, for each exam, there was a multiple choice part and there was a written part. There was a multiple choice part, there was an essay writing part. So if we want to know, okay, what's their score? So if we wanted to know what their score total on the exam, we would just add these two numbers together, I guess. Okay. So each one. So now if we want to say, okay, what is, let me insert a text box to show this. Okay. So if I wanted to say, okay, what was the third student, what did the third student get on the second exam in the multiple choice part? Well, I would say, okay, the scores. All right. Want the third student, second exam, multiple choice part. Okay. What do you guys think? So why don't you answer this in the chat window? Okay. So I want the third student, second exam, multiple choice part. What was their score? So in the chat window, I want you to write how you would write the code to get that and what is the value. A lot of different answers here. Good. Give a couple of more moments for you guys to think through it and suggest answers. Okay. All right. So what we'll say is, okay, those of you who said, okay, third student, yeah, it's zero index. So the first student is actually the zero indexed. So the third student, I'm going to need to use the 2 to get them. All right. Then the second exam, same thing. I'm going to need to use the 1 to get that. Now, what we said was the multiple choice part for each of these would be the first value in each of the arrays. So the first value means I'm going to use the 0 index, right? So what'll happen is it'll go 0, 1, 2. Okay, so this is my array index 2, so which represents the third student. Then array index 1. So this would be array index 0. This would be array index 1. Okay. So now I've narrowed it down to this array. And then I want the multiple choice part. We suggested that the multiple choice was the first value in here. It's not entirely clear based on this description, but I'm going to say that's how we're going to take it for today. So I want the multiple choice part. So I want this first value there, which would be index 0. So the value is 9.4. Okay. If I wanted to say, okay, what's their total score? Not just the multiple choice part, what's the total score? Then what I would do is scores 2, 1, 0 plus scores 2, 1, 1, and I 1. All right. So if I added these two together, then I get the sum of both of these scores together. Okay. All right. Unfortunately, I can't just say, give me this, because again, this does not represent a value. This represents an array, specifically a 2-item array. Okay. All right. Moving on. Some calculating the total scores could be an example we can talk about using this multidimensional array. You know, the weather information. These are all examples that you can look at. All right, we talked about the guessing birthday a while back. So there are a couple of specific things I want to go over in our example time here today. So let me go ahead and pull up the J graph so you can see that. There it is. Okay. All right. So the couple of examples I wanted to do with you guys today was the grade the exam and the let's check the Sudoku solution examples. All right. So here, notice we have a single one-dimensional array. A one-dimensional array that represents the correct answers to our multiple choice test. All right. So it's, well, how many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And then each of these is the answers for some students. So 1, 2, 3, 4, 5, 6, 7. So 8 students. 8 students submitted answers, and we want to check what their grades are. So what we need to do is basically we need to say for each student, so we need to take this one array, and for each student we need to go through and match this value to this value. Is it correct? If so, give them a point. If it's not, do not give them a point, and so forth. So we go to the second one and the third one and the fourth one and so forth. All right. So what we need to do, all right, so we need to say, okay, the outer loop says we're going to do this for each student. So the outer array, because each of these subarrays represents one student. So this array is one student's answers. This array is a second student's answers. So this outer loop for to answers.length says each time through the loop, we're going to grade one student. We're going to be looking at one student each time through the loop. We initialize how many they got correct to 0. The reason why we initialize it to 0, they haven't gotten any correct yet, have they? We haven't checked their answers, so we don't know how many they've gotten. Now, for int j equals 0 up to the first array, for the I array, whatever the value of I is, dot length. So we're going to be going through the student's set of answers. Could we have gone through the keys.length? Could we have said, you know, keys.length in this situation? Sure, there's no problem with that. We could, because then what we're saying is we just want to go through each item in the key and check it against the student's answers. It's the difference of saying we're checking, we're going to loop through each of the values in the answers array versus we're going to loop and check it against the key value versus we're going to go through all of the correct answers, the key values in the key array, and check it against the student's answers. It's the same thing. It's just different wording. Okay, so in this particular situation, we could do it this way. We could also do it keys. It doesn't matter. Okay, all right, but we do have to have one of them, and we have to put something there to choose one. All right, so basically, if the value in the student we're looking at their answer for that particular question we're looking at, if it matches the key value, then we say add one to their correct count. Say they got one right. Notice there is no else. Why? Because the else here, correct count equals correct count. Right? There's no reason to do that. Like it already does equal that. We don't have to set its value to be the same value, right? So we just don't do anything. If they don't get it right, we don't do anything. And then finally, once we're through with this inner loop, we say, okay, that student, whatever, student 0, student 0, student 1, student 2, so forth. Their correct count is whatever the correct number they got was. Okay. So if we compile it and run it, let's see, let's go through student 1 and just see. Let's go through the first student and see what they got. They got A, D, nope. B, B, okay, 1. A, D, no. C, C, 2. C, C, 3. D, D, 4. E, A, nope. E, E, 5. A, 6. D, 7. So they should get it. So they should get a total correct count of 7 for student 1. So let's see if that's right. For student 0, 7. Yep, good. Okay, so were we right and the computer confirmed that we were right, or was the computer right and we confirmed that it was right? Good. Philosophical question. Okay, now there is one interesting thing is none of you are student 0, right? We normally would count student 1. We would normally start counting with student 1, right? So how can we change this to be, instead of student 0, student 1's correct count is whatever? Is there a way we can change it to where it says student 1, 2, 3, all the way up to 8? Somebody has an answer, right? Yeah, in the print line. But here's gonna be something interesting, right? If we do this, is this gonna work? Let's see what happens. Oh, student 01, student 11, student 11, student 21, student 31. What? Right, those of you who are now saying add that parentheses thing, the reason why is because the first time that our compiler, first time that we execute this and we see this plus sign, it says, okay, that's string concatenation. So the second plus sign does the same thing. Remember, these operations are done left to right. That whole order of operations, we called it PEMDAS when I was younger. It stood for parentheses, exponent, multiplication, division, addition, and subtraction. Can't remember. Somebody told me what the Turkish equivalent was, what the Turkish one was. I can't remember what it is. But if we put parentheses, then we're saying, okay, do this before you do this. So now we're adding 1 to an integer before we concatenate our strings. So now if we compile it, now it should work. There we go. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Okay. All right, so that's how we can check these each one through. Remember, in a multi-dimensional array, we're going to need 2 loops in order to get to every value. Okay. All right. Let's talk about how to check a Sudoku solution. All right. Now, in this example, I think read a solution, we have to enter the puzzle solution values. Let me go ahead and do that. I'll do that in just a moment. Now, notice one thing here. This method read a solution, it returns a two-dimensional array, which means inside of this method, I create a two-dimensional array. I then fill it with all of the values that the user is going to enter, and then I return that. I just return that. Notice I don't have to return this. Why? Because this, I don't have to return something like this, right? Because these are saying, give me the index, give me the thing at that index, which in this particular situation, if I did this anyway, I'd get a runtime error anyway. All right. But what I'm saying is I want to return the whole array. I want to return the whole multi-dimensional array back. Okay. So I declare, I create this two-dimensional array of 9 values each, 9 by 9. I return it, I populate it, then I return that. Okay. And then I can take that two-dimensional array and I can pass it to another method, to the isValid method. Now this isValid method is going to read this grid, it's going to read this two-dimensional array, and if it is a valid solution, it's going to it's then going to return true. Okay. So notice here I'm passing a two-dimensional array. If I were to do this, I should get a compiler error. Yep. All right. I get a compiler error because what it's saying is you're trying to pass a two-dimensional array to a one-dimensional array object. That's not going to work. So, right. So now when I build it, it works out just fine. Okay. Now, each row having the numbers 1 through 9, that's fairly simple, right? Basically, so the is1 to 9 method. Now, here's going to get something. Here's where it's going to get kind of interesting. Is1 to 9 is also going to take my first row the first time through, my second row the second time through, my third row the third time through, and so forth. Right? So if we look at that is1 to 9 method, it takes a one-dimensional array. But you said, wait a second, you said that grid was a two-dimensional array. But notice what we're passing to it. We're not passing the whole grid. What we're passing to it is just the first row in the grid. Okay? So we are passing a one-dimensional array to this method, right? Which takes a one-dimensional array. Okay. Now, what we do here is we're going to copy this list into a temporary array. The reason for this is, as we'll see in just a moment, the way that we check this. Instead of, there's lots of different ways for checking if the values 1 to 9 are represented. Okay, the way that they solved this problem is they said, okay, we'll take this whole list, we'll put it into this temporary array, and then we'll just sort it, and we'll make sure that each time through the values are correct. Like, because if, for example, our list contained one, let's say 1, 5, 3, 7, 4, 8, 9, 6, and it should be the last one, should be 2, but let's say we did 3 again. Okay. When this gets sorted, what'll happen is it'll be 1, 3, 3, right? Because there is no 2. And so what'll happen is when this checks, does the value in that position, if it doesn't equal that position plus 1. So in other words, this should be 1. When we sort this, like I said, it would be 1, 3, 3, and so forth. All right. So the value at index 0 is 1. So we keep going. The value at index 1 is not 2, so we return false. Okay, if it's not right, we just go ahead and return false. Okay. Now, some of you might be asking, wait a second, but why do we need the temporary array? Why did we need the temporary array? Why not just sort the list? Well, here's the problem. If we sort the list is the original array. It actually contains the original array. If we sort that, then we're changing our grid. And we don't want to do that. We don't want to change the grid. We just want to check to make sure that the values in the array were there. Okay. And I just had an idea that for an exam or a quiz question, what I could ask you is, how could we do the is1 to 9 method without using a temporary array? How could we check to make sure the value is 1 to 9 there without using a temporary array and sorting it? Don't answer on here, because if that shows, because it may be an exam question, okay, which is something to think about. All right. So basically, now we have this method is1 to 9 that we can use for any array of size 9 to make sure that the numbers 1 to 9 show up in there. All right, so let's go back up. I think that's the last of our methods there. Okay, so what we do is for each row, we just check. And if ever we get a false returned from is1 to 9, we simply return false there. It's like, okay, nope. This doesn't work. Why? Because if any of our rows fail to have that 1 to 9 check be correct, then we don't have a true Sudoku solution. Okay, so that was the easy one. Rows 1 to 9. Okay, now we need to check whether each column has the numbers 1 to 9. Okay, well, for j equals 0. Now, the way that they decided to solve this is they decided to create a new array, another temporary array, that represents the column values. So for I equals 1, 0 up to 8, right, is we're just going to copy into our column whatever the value at that row is. So notice we're going through each row, getting the value at that column and putting it into this new array. And then we're just going to use that is1 to 9 method on this new thing we called column. Okay, I hope this is clear what they're doing here. This is kind of like creating that temporary array. This is kind of like, you know, just copying each value in the row at a certain position into a new array to represent the column. Okay. What I may do is I can do this using the canvas and can show you what that looks like. Okay, why they're doing this. The reason why they're doing this is to be able to make use of this is1 to 9 method again. Because the is1 to 9 method takes a single array of size 9. That's a one-dimensional array of size 9. So we needed to create this array in order to pass it to this method, right? Because remember, in Java, there is no easy way to get the column representation, right? Sadly. Okay. All right. Then finally, so this basically works out the same. So now we have each row, each column has the numbers 1 through 9. I wish we were done. Because now we need to check if each 3 by 3 box has the numbers 1 through 9. Okay. And now we have a 3 by 3 grid that we need to pack into, because if we're going to do this with this is 1 to 9 again, we need to pack it into a single array, a one-dimensional array of size 9. So it's a little bit confusing, but basically what we're doing is we're going through each box. So this represents, how can I explain this? I wish I could have the whiteboard up at the same time. Let's see. Let me, actually, I think I can do that. Let me do this. Actually, I can. Let me do this. Let me just share my whole screen. Okay. So here, this loop here, if we look at it like this is our Sudoku grid, okay? 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Up one more. Okay. 1, 2, 3, 4, 5, 6, 7. I think that's one shy. 1, 2, 3, 4. Okay. So if we think of it like this, that what we're trying to check now, so far we've done, I'll use a little green thing here. We've done all the rows and we've said, good, they all worked. Then we took all the columns and we basically transposed them into a single 9-element array and passed that and checked all of them and got true for all of those. So good, we're good so far, right? Okay. Now what we want to do is we want to check each of these, right? Each of these 3 by 3s. All right. So we want to check each one of these and make sure that those are correct. So we need to somehow figure out a way. Let's take this for each of these 3 by 3s and put it into a 9-value array. Oh, 1, 2, 3, 4, 5, 6, 7, 8. No, I put way too many. Okay. And then we want to take this and check it for if the numbers 1 through 9 appear. Okay. So how do we do that? Well, this outer one, if we think of it as this is a 3 by 3 of 3 by 3s. Okay. That's no. I don't want to lose you on this because this is. So we look at it as these are the 9 3 by 3 blocks we want to look at. Okay. Notice that 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of them. There's a 3 by 3. That's what we're doing here with these outer 2 loops. The first time through, I is 0, j is 0. That's this one right here. The second time through, I is 1, j is 0. That's this one right here. The third time through, I is 2, j is 0. That's this one right here. That's 2, 0. Okay. Next time through, I is 1. Okay, now we're down to this level. J is 0. That's this guy right here. Okay. So we're going through each one. And that's what these 2 loops are. So, so 1, 2, 3, 1, 2, 3, 1, 2, 3. All right, so that explains these outer 2 loops here. Okay. Then hold on just 1 second. Okay, so that's what we're doing here is we have this, so I is this row, J is the columns. Okay, now the starting element in the small 3x3 box, K is 0. All right, so we're just saying go. Let's go through just K is starting at the index 0. Again, we're going to create that list of 9 values, and we're going to populate it. So basically what's going to happen is, let me do a different color, green. This value here is going to end up in there. This value here is going to end up in there. This value here is going to end up in there. Then we're going to go down and do the next one, right? And so forth. Okay? And I hope you understand how this is happening. These 3 values are going to end up in these 3 positions. These 3 values are going to end up in these 3 positions. These 3 values are going to end up in these 3 positions. Okay? So that's what all of this complicated math is all about. Is what we're saying is, okay, I want to go I times 3. So the first time through, 0. I is 0. It's going to go up to 3. The column is going to go J. J is 0. J up to 3. And it's going to keep adding 1 to it. Right? Each column. So what's going to happen the first time through is pretty simple. It's going to go 0, 1, 2, 0, 1, 2, 0, 1, 2. It's going to take these and put them into here. Then it's going to check that new list. Assuming it's true, then we go back. Now let's get a little bit more complicated. Let me go all the way to the last one here. Okay? Because when we get to the last one, I is 2, J is 2. Okay, when we're processing this last one here. Okay, so we start off with K is 1, K is 0, sorry. Okay, so that's this position here is what we're going to start with. Now, I is 2, so we're going to go from row being what? Row is what? The first value for row is 2 times 3, which is, anyone? 2 times 3, 6, right? Column is the same thing. Column is also 2 because J is 2 times 3 is just 6. Okay. Yeah. So the first value in our list is going to be the value from our original grid, index 6, index 6. Well, where is that? Okay, let's take a look. Row 6, so 0, 1, 2, 3, 4, 5, 6. So this row. All right. Column 6, 0, 1, 2, 3, 4, 5, 6. This value. This value is going to be put into this position. Notice what we've done. We've accessed this set of 3 by 3. So let's see what happens as row goes up, because row is going to go up by 1 3 times, right? It's going to go up by, it's going to become 7, and it's going to get, let's see. Sorry, column will be messed with first. I'm sorry. Let me undo this. So column will become 7, where I'll get this value. Column will become 8, where I'll get this value. Then once column becomes 9, notice what happens over here. 9 is not less than 9. So we're done with this loop. We go back to this one, and we add 1 to row. Row becomes 7. Column becomes 6 again. And now we're going to look at row 7, this row. index 6 this value. So now this one gets put into here. So notice what we're doing now. We're taking this 3, putting it here, this 3, putting it here, this 3, putting it here. Okay. And then once we have all of this into this list, we take that list, we check, is it 1 to 9? If true, then yes. Okay. I know this is a bit confusing. Okay, I understand that. I do want you to be able to look through it and understand what they're doing here. Absolutely, this is not the only way to solve this problem. Okay, there's lots of ways to be able to check a Sudoku solution for correctness. Okay, we don't have to create this is 1 to 9 method. We could have done something else instead. Okay, but this is a way that the textbook authors chose to solve this problem. Okay, and I do say that you need to be able to understand why this solution works. Again, I'm not asking you to come up with this solution, that this solution has to be the way that you would do it, but I would like you to be able to look at code like this and be able to understand why it works correctly. Okay. There's one other thing I want to do. We're running up against the edge of the second break time, so there is something else I want to make sure we cover today. Is there a question? Nope. Okay. There is one thing I want to be able to cover today. If there's no questions on the chat. Okay. Good. So there. Let's go ahead and take a break. And this is I want to be able to talk about this whole ragged array, some special ways that we can create a ragged array. Okay? All right. Is there any questions? Nope. All right. So we'll take a break now. We'll go ahead and stop the recording.